So how we do this problem? Does this circle mean anything to you graphically? Does anyone remember the circle equation? All right. So this
No.
is what it would look like. So x minus h squared, but not cubed, plus y minus k squared is equal to r squared. And we don't know the radius. We can find that out in just a second. So the center is negative 1, 1. And if hk is a center, then h is negative 1 and k is 1. Obviously, right? Everyone's following? So let's set that here. Okay, and everyone's fine with how I got to this point, right?
Mm-hmm.
Okay, good. So let's put that other point they gave us, 5 comma negative 4. And we have to keep expanding this until it touches. And that's going to help us a little bit. Okay. It looks like we have a radius just right. And to recap, Desmos suggests that I don't have a variable defined here. So it gave me a slider. And I'm going to use this slider to find how big the circle should be to meet this point. Make sense? Okay. And the next step. It's asking us about the tangent line here. And which of the following would also lie on that line? Does anyone have any ideas how we could proceed with this? If we have, this tangent line here crossing through. What we can do is simply plot the points and we can just envision the line. So I'm going to just plot them all real quick. 9, 2, 11, 1. And let's recall what a tangent line is. It should look something like this, right?
Yes.
And which of these has that? Well, obviously not the black one. That one's all the way up here. That's not even like horizontal either. This green one's like getting skidded off. That's not exactly a tangent line. The red one's nowhere. So our answer is just this blue point. Does it make sense how we got this answer? This has to be on the tangent line.
I have a question.
Yeah.
So, is knowing the radius, like, do we need to know that to answer the question?
Technically, you don't have to, but it would help you with this illustration here, since that's how we solved it. You would have had to do a lot of algebra, which would burn time on this. Okay, so I'm going to select 10, 2. Correct. Let's move on to the next one. I'm going to do a few more circle equations, and then we can move on. Let me make sure I didn't miss any messages here. Okay, so let's search this and move on to the next one. The graph of such and such in the xy plane is a circle. What is the length of the radius? So with this question, I'm going to begin by just graphing it first. I don't want to complete the square and all that right now. If it turns out that it's an ugly answer, then we'll see. So let's see, plus y squared plus y is equal to 1/9/9. Okay. So we're getting here. Also, one thing to notice here. These little gray points, that's not like the rightmost point. This is just the x-axis. So let me bring rid of that. There. What another strategy you could do is just find distance from the top to the bottom, right? So let's do just that. 9.5 all the way to 10.5. So our diameter is 20, which means our radius is what?
10.
Yep. Correct. All right, what are the coordinates of the center? This one's pretty trivial with Desmos. Let's just get on graphing with this. Notice a lot of the circle questions, you could just graph them and see. So, okay.
Will we have a Desmos like on the actual test?
Yes, Desmos is provided to you on the SAT and pre-SAT.
All right.
So let's get graphing. That's obviously not it, right? You can extract that out if you're using that feature. Next one, negative 10, comma 8. Nope, that's not it either. 10, comma 8. And let me make sure I graph this right. Yeah, okay, we're good. And let me put this x-axis back. Make sure I didn't miss a sign here. There we go. Yeah, the blue one here is the right answer. We can just plot all of them and see which one is coinciding. Okay, correct. Moving on to the next one. Okay, we get another tangent line question. Okay, so we have a center at -4, comma 6. -6. And let me see if the circle equation is provided to you. Okay, no. So you're going to have to remember this. X minus h squared plus y minus k squared is equal to r squared. Again, where the coordinate h comma k is the center and r is your radius. So if the radius is 8, this thing on the right side should be 64. So let's get that in. We're going to have x plus 4 is minus 4 squared plus y plus 6 squared. And we don't know the radius either, so let's just leave it as r squared and make a slider for that. Like the other problem, let's plot the other point and see when they meet. Because if it's tangent, it has to be touching at least one point, right? Okay. Looks like we have a match there at around 3. And line K is tangent to the point at -7. So again, to visualize what this might look like, the line should look something like this. At point -7, comma -7. What is the slope of line K? You could just draw it out like this and see what's happening. So yeah, you can do that. You can use point slope form here, since we have a point and a slope. To recap, this is point slope. Y minus y1 is equal to m times x minus x1. And this is the easiest form if we're provided a slope and a point. And in this case, since we have the point, we can just try all the slopes given after that. So this is going to turn to y plus 7. Y plus 7. And let's just try them. Okay, -3, does this look right? It looks pretty good, so let's keep that there and try the other ones in the process. -1/3, that is definitely not a tangent line. Let's try 1/3, y plus 7 is equal to 1/3. X plus 7.
I have a question.
Yeah.
So can't we just find the slope between the center and the line and then perpendicular slope of that?
Yes, that is an alternate method.
Okay.
And I would say that might be even the best method here. But if you're not familiar with this kind of tricks, because you know this thing,
Yeah.
these are perpendicular, then you can do this. I will showcase that method in just a second. Okay. So just from looking at them all, these two are obviously not it. And what about this black one? I don't even know what this one would be called. This is just a secant random one. Okay, so looks like our best answer is -3 there. And the alternate method that was proposed is to use the center. Because the tangent line is perpendicular, we can just find the slope of this line and do -1/n. And you get the same answer. Everyone's following along? I'm not going too fast?
Everything's good.
Okay. Oh my, another one of these. Let's do the same exact thing. Let's 2x squared. These kind of questions are your best friend, since you can always just graph them and get 3 points. So -6x plus 2y squared plus 2y is equal to 45. What's the radius? And again, don't be fooled by these little points, because this is just the x-intercepts. That's not necessarily like the rightmost point. Okay, so we're gonna do the safe strategy again, just top to bottom, and find the distance. So 4.5 to -5.5, that's a diameter of 10. So what's the radius? 5. Okay. logical. I'm gonna skip this one because I think this is the one that had a wrong answer. Okay, this is a good one. And this one you can't really do on Desmos, so I'm gonna copy it over to Inkscape where I can draw on it. Okay, a circle has center G and some points lie on the circle. Line segments MH and NH are tangent to the circle at points M and N respectively. If the radius of the circle is 168 millimeters and the perimeter of quadrilateral GMHN is 3856 millimeters, what is the distance in millimeters between points G and H? That's a lot of words. Let's start from the beginning. We've got some circle here. There you go. I'm trying to capture my mouse pad here. Okay. And we've got G at the center. Okay, let's also add in M here. And as a friend, we can add the N. And line segments MH and NH are tangent. So that means we have added a new point, H. And I'm going to put this like right here, so that they can be perpendicular. If these are tangent lines, it's going to look something like this, right? And let's connect the radii. Okay, and what is this asking now? What is the distance in millimeters between points G and H? Okay, this is going to be interesting. So let's trace this shape again. Again, make this a little clearer. We know that the radius is 168. 168, 168. And that these lines, for being tangent lines that meet a point, they must have the same length. So x and x. And we also know the perimeter, so we can just add all these and they must equal 3856. And to do this quickly, you can use Desmos. And I'm going to try to illustrate a quick algebra shortcut you can do on Desmos. So we have 168 times 2 plus 2x is equal to 3856. But the issue with putting an equal sign is that you're going to have to zoom out, zoom out, zoom out, zoom out, find your answer. And what you could do as an alternative is use a squiggly line with a different variable here, 2L. And it's going to tell you directly what it's equal to. This is helpful when you have the long algebra. You just put a variable that's not x, and then the tilde here. It's going to solve it for you. Okay, so we have that x is equal to 1760. 1760 and 1760. And we want the length straight across. Okay, straight across. Let's just draw that line. And oh, would you look at that? It's a right triangle. And we know this is a right triangle because this is a tangent line. This is going to be 90 and 90. Okay. So since we have 168 and 1760, we can apply the Pythagorean theorem. Square root of 1760 squared plus 168 squared. We get the final answer of 1768. Did that make sense for everyone? This is one of the harder problems, I'd say. Everyone's good? Okay. You guys know the drill for this one. You can just, if you can't picture this, you can just graph them all. Yeah, okay, that's definitely not it. X minus 8 plus minus 8 squared equal to 16. Okay, those are just the same answer choice. I think someone made a mistake, but let's keep going. Oh, would you look at that? We got exactly one axis cross, so we're done. Check answer. Done. Okay. Since we've done 8 of the 14 hardest circle problems, I think we're good now with circles. And about this, for some reason, it's called 1600.lol. It's an SAT question bank that also has PSAT problems. Okay. Let me go to the PSAT curriculum here, which I think is the same actually. Let's see if we can do right triangles in trigonometry. Okay. Triangle. Okay, since these are trigonometry, I'm going to move this drawing thing over here and move Desmos to the side. Let's get that triangle in. Let's say this is F, G, H. I'm not going to worry about scale. It's only the ratios that matter. Okay, it's similar to JKL. Let's just assume this one's a lot bigger. Okay, another thing to notice here is that when you make a similar figure, you have to follow the order you did here. So here I went kind of to the right and then back up. We have to follow that same order with the letters so that they correspond. JKL. Okay, we've got some ratio here. Sine of this is equal to that. And what is sine of J? So the thing to notice here is that if this is, okay, let's just say opposite of hypotenuse. So okay, this is a horrible diagram, but whatever it is, like let's say 308 over 317. The sides for this one are just going to be a scaled version of that. So it's going to be like 308 times 2 divided by 317 times 2. And since it's similar, and we have the product here on the top and the bottom, we can cross it out and the ratio is the same. So 308 over 317 is our answer. It's the exact same because it's a similar triangle. The ratios are the same. Correct. Moving on. Okay, let's do this one. In right triangle, SRST, the sum of the measures R and S is 90 degrees. Okay, so that means I have to change this drawing a little bit. RST, R and S. Okay, we're good now. The value of sine of R is, I'm assuming it's gonna be a square root because there's just like a blank space there. And if it's wrong, we can go back and change it. Okay, so sine of R is equal to square root of 15 over 4. Okay, so let's label that. Since this is opposite over hypotenuse, this is square root of 15 over 4. Sorry, square root of 15, 4. And we need to find the cosine of S. Okay, this is just going to be the adjacent divided by the hypotenuse. So it's just the same answer again. And this actually generalizes. So if they give you a right triangle and they give you one of the acutes, like here, so this is x and this is y, the sine of x is always going to be equal to the cosine of y. So they give you some angle in another one, you can match them like this. And same other way for sine of y is equal to cosine of x. in right triangles when we're dealing with the acutes. Any questions about this one? All right, I'll assume y'all are good for this, so I'm going to keep moving. Okay, we've got more of these now. Okay, x, y, z, and z has to be the right angle. So z, x, y. The length of yz is 24. Make that a little better. Yz is 24. If tan of x is equal to 12 over 35, what is the perimeter? Okay. So do we remember what tangent is equal to in terms of triangles?
Opposite.
Adjacent.
Yes, opposite of adjacent is correct. So we have over A. And in this figure, it's going to be equal to 24 over, I'm going to call this, what's a cool letter? A for Asian. And this can be B. Okay, so we've got that is equal to 24 over A. And let's look at what the problem told us. It told us that tan of x is also equal to 12 over 35. So you could cross multiply this, but I'm going to use the same Desmos algebra trick. We've got 24 over A, squiggly line, 12 over 35. We get that A is equal to 70. Okay, so we can cross this out. We've got 70. And for B, we can use the Pythagorean theorem like always. $74. And adding these up, we get, this would be 144 plus 24, so 168. Everybody follow that?
Yeah.
Good. So this next one, oh, these are really good because you just look at it. So we've got the opposite of A divided by the adjacent of A. 20 over 21. I don't think there's much to say about this. And the worst thing is that that's actually not even an answer choice. That's yeah, like I said, sometimes these have issues, and it's kind of funny that this easy one's the one that has it. So we're going to keep moving on, but the answer should be 20 over 21 since it's opposite over adjacent. All right, here we go. What is the value of cosine of A? And they've made a little trickier here since we might not know what the opposite here is. But let's do what we know. So we've got adjacent over hypotenuse for cosine. So our answer is simply going to be 41 over 42. Next. I'm not going to risk this one. Looks like this one rendered it incorrectly. Okay, let's do this one. I think the answer is 24, and I'll walk through how I did that so fast after I use this standard method. Okay, I've got 26. If B, whoa, C, and A. So sine of b is equal to 5/13 as given. But in our diagram, it's going to be equal to opposite over hypotenuse. So O over the hypotenuse, which is 26. And this is going to be 10. Again, you could use the Desmos tilde, or think about it, since this got doubled, this must also get doubled. Okay, nice. So the opposite here is going to be 10. And then we can solve this triangle. So we have that this squared plus that squared is equal to 26 squared. So where is Desmos here? There it is. 10 squared plus some length squared is equal to 26 squared. Okay, our answer is 24 indeed. And let's walk through how you can tell that by just looking at it. There are these things called Pythagorean triples. There are things you just know for a fact must make a right triangle. The ones I would recommend knowing if you want to get really fast at these are 3, 4, 5, and 5, 12, 13. And that also applies to multiples of these. So this could also be 6, 8, 10, or even 0 0.3, 0 0.4, 0 0.5. And in this case, these were 10, 24, and 26. Okay, so let's recall what is the length of BC. It was 24. Next one. Yeah, you might notice we have a lot of these, and I think that's also true on the SAT, PSAT. They just ask you to find the ratio. And also notice here, they don't give you this sign because you're not required to find it as part of science. That's a little hint. So as normal, opposite over hypotenuse, 35 over 171 is our answer. And I think that will be enough for trig, unless you guys want more practice on that. Where is the math? Are there any of these that you guys would like me to cover in particular, or can I just choose any of them?
We will put advanced math.
Okay, advanced math. Let's see what advanced
Also,
math has
like,
to offer. Yeah.
also anything like within math that is like most common on the PSAT.
Okay. So, wow, this is a really challenging problem. I'm gonna change the difficulty, since that's just length times width. Okay, let's make it the hardest. So we're getting super duper advanced math. This is a joke, but let's do it. Okay, so we've got x times y, since we don't know them, is equal to 462. The first integer is 5 greater than twice the second integer. So we've got y is equal to 2x plus 5. That makes sense so far, right? And now that's just the system, so you graph it. Okay, xy is equal to 462, and y is equal to 2x plus 5. Okay, we've got these two answers, and let's see which one to choose. Okay, and since they must be positive, it has to be this one. 14 and 33, so the answer is 14. Need to find that. 8x plus 23, 4. And where's that? And we get 1728. And notice here that it asked about the value, not the minimum x, or where does the minimum occur? It's asking just for the minimum, which is 1728. Okay, this looks more like the ones you see on advanced math. Okay, in the xy plane, a line with equation 2y is equal to 4.5 intersects a parabola exactly 1 point. If the parabola has equation y is equal to negative 4x squared plus bx, what is the value of b? So let's go to Desmos again. We have 2y is equal to 4.5. And now this parabola, negative 4x squared plus bx. And we don't know bx, so let's just try all these values. Okay, and it's got to touch it exactly once, so let's keep zooming in to see when this happens. It happens at b is equal to 6. Okay, here we go. If the square root of something divided by the cube root of something is equal to x, so a over b, what is the value of a over b? Okay, so these are just exponent properties. So we have x to the 5th raised to the 1/2 power, all divided by the cube root of x to the 4. Make sure and here. Okay, so for the top, when you have an exponent to an exponent, you just multiply them. So that's going to be x to the 5/2 divided by, and this is going to be x to the 4 raised to the 1/3 power since it's a cube root. So x raised to the 4/3. And for the final step, since we're dividing this x, we just subtract the degrees. So x to the 5/2 minus 4/3. Let's see what that is real quick. (15 minus 8 is 7 over 6. Let's double check that. 5/2 minus 4/3. 7/6. Yeah. And a lot of people don't notice, but when it gives you a decimal answer like this, sometimes you'll see a little fraction here. When you press it, it turns it back into fraction form. So let's submit 7 over 6. And that's correct. Okay, let's do this one. Function f is defined by f of x is equal to negative ax plus b, where a and b are constants. In the xy plane, the graph of y is equal to f of x minus 12 has a y-intercept at 0, negative 75 over 7. The product of a and b is 320 over 7. I'm going to write that down. It seems important. So we have ab is equal to 320 over 7. And what else? Negative a over x would be. Okay, and let's plug that into this thing here, because we know the y-intercept. So we can do some algebra if we plug in 0. So let's actually do that. Negative ax plus b minus 12 is our new thing here. And we know that whenever we plug in 0, we must get this in return. So let's do that. Negative 75 over 7 is equal to negative a to the 0 plus b minus 12. Okay, and now we have one equation and another equation linking a and b together. We can just graph them as a system. I'm going to change them to x and y. 320 over 7 and negative 75 over 7 is equal to negative a to the 0. If you're not sure what that is, Desmos can just do it for you, so it doesn't really matter. 0 plus b minus 12. Changing these back. and we get this intersection. Let's see what it is. Okay, and thankfully they're asking me for the value of a because this is pretty long. So 20 and correct. Okay, sadly this one also looks like it got messed up along the way. The function f is defined by such and such, where a and b are constants. In the xy plane, the graph of y is equal to f of x has an x-intercept at 2, 0, and a y-intercept at 0, negative 323. We can do a really similar strategy for this one. So if it has a y-intercept at this thing, let's just substitute that in. So negative 323 is equal to a to the 0 plus b. Or actually, you could just solve this straight away from here. Since we know what a to the 0 is, that's just 1. So negative 323 squiggle is equal to 1 plus b. Negative 324 should be our answer. Yeah, and for these kind of questions where you could just solve it in one go, you may not always know it. This just happened to be a coincidence here. Okay, let's see this one. Culture of bacteria is growing at an exponential rate as shown in the table above. At this rate, on which day would the number of bacteria per millimeter reach 5.12 times 10 to the 8? Okay, now I want to make sure everyone's listening for this one because this has a really important skill. And
Yeah, Adrian, what are you covering?
Yeah, we're covering advanced math for the PSAT math. This is one of the topics.
For PSAT?
Yeah, and this one also
Okay.
applies to SAT, so let's see what
Oh.
I'm talking about. I'm talking about regression. Regression is when you have a set of points and you want to find the rule. So let's plug that in. 1, 2, 3. I'm going to go through it again. I click on the plus sign and I click table. X, Y, 1, 2, 3. 2.5 times 10 to the 5. 5.0 times 10 to the 5. 1.0 times 10 to the 6. And I'm not sure
Adrian,
if...
Adrian, if you mind, may I say something? Because I've already taken the PSAT and I got a pretty decent score on that SAT math.
Mm-hmm.
So for in terms of make sure you pay attention to what Adrian's about to say for regressions, because that saved me a lot of math portions. Anything that's not a word problem, it's probably 90% of times you can use a regression for it. It literally tells you the answer. It doesn't you just have to know how Desmos works or your calculator if you don't know how to use the Desmos. But learn Desmos; it's much easier. That's all.
Yeah, Yannick is totally right. They're often going to give you these tables and ask you to find a pattern or a number in between these. Okay. And I'm going to assume it doesn't do it for us here on the PSAT. So I'm going to show you how to do it normal way. So we're going to put what we usually do. So we have y is equal to a times b to the x, or an exponential pattern, right? But Desmos is not happy with us because we're putting an equal sign and we haven't established anything. We have to put our variables also in this table. Okay, so y is equal to a times b to the uppercase x. And the final step is that for regression, we don't use an equal sign. We use the tilde, which is that. Okay, and now let's see, when do we reach 5.12 times 10 to the 8? Y is equal to 5.12 times 10 to the 8. And we just gotta zoom out, see where it crosses. I'm holding shift and dragging, by the way, to get this x-axis smaller. There it is. Okay, so it's on day 12. And that's correct. Did this process for regression make sense to everyone? So this is an important skill for the SAT. Okay, so that's good. Let's keep moving. Wow, that's a lot of problems they have. Okay, I'm not sure what this is supposed to be. I really hope you guys can do this one. So let's do the same thing, 2x squared minus 2, 2x plus 3. Let's look at the solutions. These are not nice numbers, so we can just match them to what's present here. Let's see which one's really close. And just for clarity, if you're not sure what I'm doing for the square roots, I'm typing SQRT. Okay, let's see which one of these is really close to what we got here. 2.15831. Well, we got a friend here. Okay, so let's cover the problem I got sent. And this was going to cover a trick that isn't very well known. They're called Vietta's formulas. So let's do this. And the solutions to x squared plus 6x plus 7 are R and S, where R is less than S. The solutions to x squared plus 8x plus 8 equals 0 are T and U, where T is S and U. And the solutions to x squared plus 14x plus C, where C is a constant, are R plus T and S plus U. What is the value of C? Okay, look at this one more time. R and S, or T and SU. Okay. I'm trying to think of a fast way you could do this, since you might have to solve with a quadratic formula. Okay, let's solve it as usual and see if our answer can get close enough so that we'd have to avoid that. So x squared plus 6x plus 7. We get these solutions, so I'm going to copy that here. And this other one, I'm going to copy that there. And remember, S is the bigger one, so this is S. We label that. And this is going to be R. The solutions to this one are x squared plus 8x plus 8. Cover those up for now. Let's put those down as well. Okay, and U has to be the bigger one again. So this is U. And this is T. And the way we can try to construct this quadratic is now with these as roots. Because if we know the roots, you could just plug it in like this. X minus A times X minus B. Where A and B are the roots. Okay, so now let's find this. Since one of the solutions is R plus T, it's going to be X minus R minus T times the same logic for this one. X minus S minus U. And we can plug in what we found them to be now. This is the U value. This is the S value. And we can plug in the R value here. Okay, let's see what our constant is now. Okay, and here we get our answer, 31. And we could assume that 0.0001 is from rounding in between, since we didn't use, like a zillion decimal places. It's asking for C, we used 31. And that is our answer. Did that explain how to solve it?
Yes.
Okay, good. So now we can go back to these. Okay, here we go. If 4a over b is equal to 6.7 and a over bn is equal to 26.8, what is the value of n? Since we got too many variables, we got to use Desmos on this one. So not Desmos, just my algebra. So 4a over b is equal to 6.7. And given that, you can just multiply both sides by b. 4a is equal to 6.7b. And a over bn is equal to 76.8. Let's substitute now. Since we've got... Okay, yeah. Divide both sides by 4, so we get a by itself. A is equal to 6.7 over 4 times b. And we can plug it into the next form. So we have 6.7b over 4 all over bn. Let's see what that is real quick. 6.7 over 4. So 1.675 over b over bn is equal to 26.8. And we're going to see why we substituted that in the first place now. Because now we can just cancel out the b's like this. And we're just left with 1.675 divided by n is equal to 26.8. Okay, so let's use the squiggly command for this. For n is equal to 26.8. Okay, that's correct. Let's keep going. This is another dimensional analysis question. So the density of a certain type of wood is 353 kilograms per cubic meter. A sample of type of wood is in the shape of cube. It has a mass of 345 kilograms. The nearest hundredth of a meter, what is the length of one edge of the sample? Never mind, there's no dimensional analysis for this. So density is P, and that's equal to mass over volume. So mass of 345. Okay. So if we know that the density is 353 and the mass is 345 kilograms divided by volume. So the volume of a cube is going to be x cubed, and we just solve from there. 353 this 345 divided by n cubed. Okay, and to the nearest hundredth, this is just going to be 0.99. Correct.